Oh, hey, I didn't see you there. I was just looking at light being emitted to me in the form of a computer screen so I can surf the internet. Um, Not that special, really. Well, hold on. But how fast is light? As a matter of fact, what is light exactly? Now, light is measured in wavelengths, and this right here is the electromagnetic spectrum. And that thin little rainbow line are all the wavelengths of light that we see with our own eyes. We call that visible light. All the colors we see and perceive are in that thin little line. Now, if you look to the left of it, you can see ultraviolet, X-rays, all the way down to gamma rays. And if you look to the right of it, you can see infrared, microwaves, all the way up to radio waves. Now, those are wavelengths of light that give off light, but just light we can't see. Our eyes are only adapted to see that little part of the electromagnetic spectrum. To prove the point that there is light coming off of things that we just can't see, take a TV remote for example. It gives off light at the front to communicate with the TV, but just light we can't see, but phone cameras can. Try this at home. Grab a TV remote, point it at your eyes while clicking a button, and you see no light coming out of it. But pointing at the phone camera, start clicking some buttons, and you see that sort of purplish light shining through. If you point it back at you, you see nothing. Now, that's cool and all. But how fast is light? Well, let me build it up for you. The average speed for a running male, 18 to 34, is 3.68 meters a second. Now, that's not bad, but the fastest person in the world can travel at an amazing speed of 12.27 meters a second, which is incredibly fast for us humans. But we can go faster. The speed of sound. The speed at which sound travels is 343 meters a second. But the speed of light, the fastest speed you can go in the entire universe, the speed at which a photon of light travels is 299,792,458 meters a second, which is basically 300,000 kilometers per second. In 1 second, light can travel around the equator of Earth 7.5 times. Cool little fun fact. The way light is created from a star, like our sun, is the photon of light is created in the core of a star, and then it makes its way through the star out to the surface. But it doesn't just go in a straight line. No. What it does is it does its big random walk, going in all directions, being absorbed and re-emitted for years, until it finally reaches the outside of the star, to where it goes into space, to wherever it's aiming, at the speed of light. Well, now that I've explained what light is and how fast it is, we can tackle the topic of this video, which is exactly that. Light travels at a finite speed. Light does not travel at an infinite speed. To put that in perspective, when you turn on a light bulb, the light has to travel from that light bulb to your eyes, because light does not travel at an infinite speed. Light travels at a finite speed, and it takes time for that light, those photons, to travel to your eye. So basically what I'm saying is, it takes time for light to bounce off an object and go into your eye to notice it, to notice a change. So you see everything of where it was and not of where it is. So yeah, we see everything of where it was and not of where it is. It's a sad limitation of our universe. Light travels at a finite speed, and it takes time for light to travel a certain distance. But I mean, on Earth, things are pretty close to us, and the time it takes for light to bounce off that object and go into our eyes is not even worth mentioning. For example, your feet are 5 to 6 light nanoseconds from your face. So it takes light 5 to 6 nanoseconds to travel from your foot to your eyes. So when a change happens in your foot, it takes light 5 to 6 nanoseconds to bounce off of it and go into your eye. But 5 to 6 nanoseconds is a very short amount of time. A time that is not even worth mentioning, really, because it's pretty much instantaneous. So why even talk about this? It's not even that big of a deal. But it's not a nothing deal. In space, things are much, much farther apart. Our own sun is 93 million miles away, and it takes light 8.5 minutes to travel that distance. The sun is 8.5 light minutes away. So we're seeing of where the sun was 8.5 minutes ago. But stars outside our solar system are way farther. The nearest star to us, Proxima Centauri, is about 4 light years away from us. If that star were to explode into a brilliant supernova, we would have no clue that would have happened, that happened for 4 years. Or a star that is 100 million light years away, if that blew up into a supernova that was the biggest supernova that we ever seen in the history of supernovas, we would never know for 100 million years. That's just a consequence of the speed of light. And yeah, that's it. That's all I wanted to say. The speed of light is finite. Even though things seem instantaneous, light travels at a certain speed. Because of that, we see everything of where it was, and not of where it is. I really hope you enjoyed this video. Please subscribe and give it a like. I'd greatly appreciate it. And I'll see you in the next video.